So let's discuss another problem in classical mechanics. So a smooth sphere of radius r is made to translate in a straight line with constant acceleration a. A particle kept on top of the sphere is released at zero velocity with respect to the sphere. The speed of the particle with respect to the sphere when the particle is at an angle of theta is. So what they have given in the question is a smooth sphere of radius r is made to translate in a straight line constant angle. So this is the smooth sphere. So here smooth sphere indicates that here friction force is zero. So as this particle is about to size, so we need to consider here friction force is zero because of smooth sphere. And next it is made to translate in a straight line constant acceleration. That means it is dragged in this manner. That means this sphere is not rolling, it's just moving in this direction, it's just translating. So here they have mentioned it is not rolling or rotating, it's just moving in the forward direction with acceleration a. A particle kept on top of the sphere is released at zero. So this is the particle kept on the top of the sphere, and this is the sphere. We are placing this particle on the sphere and we are just leaving. We are just making this bigger sphere to move in this direction, and we are just placing this particle, and if we leave, so that one they are saying. So initially this is the sphere, we are placing particle on the sphere, we are just dragging this sphere to this side and we are just leaving this particle. So we need so if we leave, it will fall towards the backward direction. Why means because of inertia, so that one we will discuss. So at zero velocity with respect to the sphere, the speed of the particle with respect to the sphere at an angle. So they are asking next the speed of the particle with respect to the sphere, not with respect to the ground. That one we need to mind here. So they are asking with respect to the sphere. So we have to consider in the sphere's frame of reference here, not the ground's frame of reference. The condition would be some other thing, but we have to consider with respect to the sphere's frame of reference. So here how to solve this is drawing free body diagram of the particle in the accelerator frame of sphere. So here it is mentioned clearly in the solution, drawing free body diagram of the particle in accelerator frame of the sphere. That means in this frame of the sphere. So as it is moving with acceleration in this, so it is an accelerator frame, and with respect to that frame we need to consider this particle, not with respect to ground. So we have to consider as if we are in this sphere and we are observing that particle's motion. So in that accelerator frame of reference we need to draw free body diagram. Why means there, because they are asking the speed of the particle with respect to the sphere. With respect to this sphere they are asking, hence we have to consider the in the frame of reference of the sphere as if we are standing in this sphere and at the angle theta. So the speed of the particle at angle theta we need to find out. So this is the imaginative diagram, and here, so let us consider this is the sphere and this is the top of the sphere, and from here to the particle has rolled towards here in this direction. Why means as here the sphere is moving in this direction forward and this particle moves backward direction because of law of inertia. So just like if we travel in bus, so initially if the bus starts to move, we would move towards the backward direction. That is because of law of inertia. In the same way, as this ball was rest here on the top, as this is moving here, so it would tend to move in the backward direction because its initial position was here. As the sphere is dragging to here, it tends to move in the backward direction. So that's why the force acting on this small particle would be in this direction, ma. So actually this sphere is moving in this direction with a acceleration. So yeah, because of law of inertia, the force on this particle would be particle on the sphere. So this entire thing is the sphere. So this is just a short diagram. So it is lying on the sphere and it moves towards the backward direction. So that is this diagram. So now because of that, force would be acting in this direction. Acceleration on this particle will be in this direction, ma. And next is normal force, that is contact force. So normal force is a contact force. So as this particle is in contact with this sphere, so hence there would be normal force. Once it loses the contact, there would not be any normal force. So it would be normal to the surface. So this is the tangent. So at any point this is the tangent, and perpendicular to the tangent is nothing but the direction of normal force, that is radial direction. So hence here we are having normal force in this direction, that is in radial direction. So this is the center of the sphere, so this is nothing but radius. So for a tangent, normal direction, that is that would be radial direction. So hence normal force will act in this direction. This is the direction of action of normal force. And next is gravitational force acts vertically downwards. So this sounds like vertical line. So parallel to this line, this. So gravitational force weight would always act vertically downwards. That is nothing but mg. So this is small m is the mass of this sphere. That is, sorry, the particle resting on the sphere. So mass of the particle, so its weight would be mg, and force acting would be ma, and this is normal force. So this is these are all the forces acting on this particle on this sphere. So this is the free body diagram of the sphere. And now we need to find out, so what we need to find out the speed of the particle at any angle theta. So for that, what we are using here is applying work energy theorem in the frame of the sphere. So again, the frame of the sphere, we need to apply work energy theorem. So integration of f dot dr is nothing but energy, that is energy of the particle. So energy of the particle is nothing but integration of f dot dr, integration of all the forces acting on that particle is equals to energy. So as here the particle is having only kinetic energy, because it is in moving, and as it is lying on the surface of the sphere. Just like if we lie on the surface of the earth, we don't have potential energy. So if we go to certain height, we would have, because of that height mgh, we would have potential energy. So here we only consider kinetic energy. So overall energy can be written as integration of f dot dr is equals to energy, that is nothing but kinetic energy of this particle. We are considering now with this kinetic energy of this particle, we are applying work energy theorem for this particle. So here half mv square energy of the particle, and f sum of all the forces acting on the particle. So normal force in this direction, so n, and ma in this direction, so opposite. So it has, if it moves in right side, it would move in left side. And gravitational force, acceleration due to gravity, that is weight of the object vertically downwards. So all those forces, sum of all those forces dot dr half mv square. Now here integration of n dot dr. So if we split this, so everything is getting added. So if we split this, we would have n dot dr plus these two, integration of ma dot dr plus integration of mg dot dr. So if we solve one by one these three terms, so integration of n dot dr is 0. Why means, so f dot dr means f dr cos theta, cosine of the angle between them. So if it is 90 degrees, then work done, just like f dot dr, if force and displacement are in perpendicular direction, then work done would be 0. The same case follows here, as here normal force is acting in this direction, radial direction, but displacement of the particle is in tangential direction. So at this point in this direction, so at this point in this direction, at this point in this direction, so tangent to the sphere, that would be the direction of dr. So as normal force is radial direction and dr is in tangential direction, which are both perpendicular to each other, so we would have integration of n dot dr equals to 0, because cosine of 90 degrees is 0. And next is integration of ma dot dr, a dot dr. So now for this, that is cosine of the angle between a and dr. So here what we need to do is, So as this is angle theta, so here it is resting, so at this point angle is 0. So if it moves in this direction, so it would be some angle theta, it would be having some angle theta. So now what we have to do is, so this line is parallel to this line. So if this is theta, then this angle would also be theta, this angle, this, as this line is parallel this line with this line, so this is theta, so this is also would be theta. As this line and this line are exactly perpendicular to each other, that is, this is tangential and this is radial direction, so 90 degrees. So if this is theta, this would be 90 minus theta, this angle would be 90 minus theta, this angle. And again this angle would be theta, here again this angle, because this is MA is perpendicular to MG, because MA is in left direction, MG is in downward direction. So if this is 90 minus theta, and this angle exactly it has to be theta. So now after resolving that, so A dot dr, so A is in this direction and dr is in this direction, because the displacement of the particle is in this direction only, like this, it is sliding like this, so that is angular direction. So A dot dr is nothing but A or d theta cos theta, or d theta y means dr is nothing but, as we know that theta is equals to L by R. So very famous formula, we know that theta is equals to L by R, length of the arc by radius of the arc. As it is just tilting to some distance, that is nothing but dr, and here R is nothing but radius of this sphere on which it is sliding. So R, and it is sliding to small angle d theta. So hence R d theta is equals to dr. Dr is nothing but R d theta and A, and cosine of the angle between them. So A dot B is nothing but AB cos theta. So cosine of the angle. So angle between A and dr is theta here. Cosine of the angle. So theta is the angle between them. So hence we are having A cos theta R d theta. If we integrate this one, and here as MA R is also a constant, it can be taken aside, and integration of cos theta is nothing but sin theta, and applying limits 0 to theta. So sin theta minus sin 0, sin 0 is nothing but 0, so we would have sin theta after the application of the limits 0 to theta, like that. And next thing what we are having here is mg dr. So integration of mg dot dr. So mg, that is angle between cosine g, that is A dot B, AB cos theta. So g dr is nothing but, so here we are having g dr is nothing but R d theta, and cosine of the angle between g and R and dr. So this is the direction of g, vertically downwards, and dr is this direction, this is the direction of dr. So if we observe, this is the angle, that is nothing but 90 minus theta is the angle between g and dr. So cos of 90 minus theta is sin theta, hence we are having this cos of 90 minus theta. So as the angle between g and dr is 90 minus theta, so cos of 90 minus theta sin theta. So integrating from 0 to theta, overall integration if we do. So here mgr is a constant, so integration of sin theta is nothing but minus cos theta. So we would have minus cos theta. So if we take minus aside and apply limits, so minus of cos theta minus cos 0, cos minus of cos theta minus cos 0, that is nothing but 1, cos theta minus 1. So if we take minus inside, cos inside, so you would have 1 minus cos theta. So this is the calculation regarding that, where we have used, so they are saying dr is nothing but R d theta, as we have discussed now, that is R d theta dot, that is they are multiplying R omega d theta they are doing. So that is nothing but dr by d theta is nothing but R omega, velocity v is nothing but R omega. So R theta dot dr by dt along with, as this is a vector, so here under d theta by dt would get cancelled, so here we would have R d theta. So here theta cap means in this direction, in the direction of, so this is the direction of theta cap. So in this, and the displacement is also going on in this direction, so this is the direction of theta cap. Therefore finally what we have is So has the overall in the three terms, this term would be 0. This normal force, this one would be 0, and this is ma dot dr. So ma r sine theta, and again this one mg r into 1 minus cos theta. So this term would get summed up. So out of these three terms, this term is 0. So these two terms. So adding these two terms, half mv square. So now what we have is m would get cancelled overall, and we need to take this to that side. So 2r. So 2 into r has to be taken aside. So 2r into a sine theta. So here we are having a sine theta, here g minus g cos theta plus g minus g cos theta. So 2r sine theta, so a sine theta, g minus g cos theta, and here we would have a v square because m would get cancelled. So if we take square root, you would be having this. So after the calculations, you will have this. So if you, after simplifications, if you do square root of 2 or a sine theta plus g minus g cos theta. So what they have asked us is velocity of the particle at a particular angle on the sphere with respect to sphere's frame of reference. So this is with respect to sphere's frame of reference. If we take ground as the reference, then it would be different. So this is the case in sphere's frame of reference. And so as they have asked in the question with respect to sphere, so we have found out with respect to sphere's frame of reference. So this is the velocity of this particle at any particular angle. So that is the problem. So thank you.